Hi all, this is Shougang Yuan from NC State University, and another member in our team is Birakara. Today I'm going to present our project about for the ECE 542. Our team focused on the cove detection and classification in the final project. So first, I will start from the motivation of our project. As we know that, given the ongoing pandemic due to COVID-19, everyone is affected, either directly or indirectly. There are many symptoms of COVID-19, including fever, cough, headache. They are quite common symptoms and can get quite complicated. Hence, it is critical to know patient's situation as early as possible. This will be very helpful to the pandemic control. So in our project, our team focused on deploying neural network models to detect and classify different types of coughs. In the first phase, we try to detect the cough audios from a variety of audios of dataset, including both cough and non-cough signals. And in the second phase, we try to classify COVID positive and COVID negative coughs. In these slides, we show our goal and progress. The fundamental problem for us is to detect the COVID positive and COVID negative coughs. Here, we present the timeline of our progress. Our proposal was to classify different types of coughs, and in the first phase, we used the original dataset provided in class to do cough and non-cough classification. We built a model to detect the cough from the original dataset. And in the second phase, we introduce a new dataset that includes different types of coughs. We try to use this new dataset and try to classify COVID positive coughs and COVID negative coughs. In each step, we made solid progress towards our final goal. In this slide, we list all the datasets we used in this project. As we mentioned before, in the first phase, we used the original dataset provided by the professor in class, and in the second phase, we introduced a new dataset that includes COVID-19 coughs and labels. Given the large size of this dataset, we only use a subset of this original dataset. In this slide, we show our method of data processing. The fundamental scheme is we cast the cough detection problem into visual recognition task. In phase 1, we use Fourier transform to convert a continuous signal from its original time domain state to a frequency domain state and feed into our model. This slide shows two examples of cough and non-cough signals after our data pre-processing. In the second phase, we use more advanced data processing scheme to extract more features from the audios. We extract 7 features in each audio and combine the features into one image, and we show this image in the left side. Due to the variable lines of the audios, we then pad them into the same lines and use a standard scaler to scale the padded data. So in the right side, we show an example of the features after padding and scaling. In this slide, we present our results for our baseline CNN model. So in the left side is the training loss and validation loss of our baseline CNN model. In the right side is the normalized confusion matrix of our CNN model. As we can see from these slides, our model can achieve around 59% accuracy in detecting COVID negative cases and can achieve around 56% accuracy in detecting COVID positive cases. So next, in this slides, I will try to present our results for the RNN model. So in the RNN model, we use So in the iron model, the left side is still similar to the previous slides. We present the training loss and validation loss. The right side is the confusion matrix after normalization. As we can see that our iron model can achieve around 75% accuracy in detecting COVID positive cases, which is much more better than our CNN model. However, The accuracy in detecting COVID-negative cases is a little bit worse than our season baseline model. This might be a overfitting problem that would need further data augmentation scheme. Thanks for listening my presentation.